Hello everyone and welcome to an exciting journey into the fascinating world of microorganisms. My name is Dr. Nilesh Babu and I am thrilled to take you through the incredible stories of key figures who have shaped the field of microbiology. So let's start. First up, let's talk about the legendary Antony van Leeuwenhoek, often referred to as the father of microbiology. Leeuwenhoek wasn't your typical scientist. With no formal training, this Dutch tradesman crafted some of the microscopes, pushing the boundaries of magnification to an astonishing 300 times. In the year 1674, he made groundbreaking observations in the pond water, teeth scrapings, and even in his old bodily fluids. Can you imagine seeing the invisible world of microorganisms for the first time? His vivid letters to the Royal Society opened up a whole new realm of understanding, changing the science forever. Next on our list is Robert Koch, a true pioneer in the fight against infectious diseases. In the year 1876, he identified Bacillus anthracis as the villain behind anthrax, making it the first time a specific bacterium was linked to a disease. Koch didn't stop there. He developed vital culture techniques that laid the groundwork for modern microbiology as we know it today. His work on tuberculosis earned him Nobel Prize in the year 1925, and his formulation of Koch postulate gave us clear pathway for linking microbes to the disease. Speaking of the Koch postulates, these four principles are crucial for understanding infectious diseases. They outline that pathogen must be present in every case of disease, be isolated in pure culture, induce the disease when introduced into the healthy organism, and finally re-isolated and identified as the original agent. These guidelines are foundational to the microbiology even today. Now, let's chat about Louis Pasteur, a groundbreaking French chemist and microbiologist. Pasteur is best known for debunking theory of spontaneous generation. With his ingenious experiment, he showed that microorganisms arises from other microorganisms, not from the air. His development of pasteurization helped save countless lives by eliminating harmful microbes in food and drink. Plus, he created vaccines for anthrax and rabies, providing that weakened pathogen can provide immunity. Moving on to Joseph Lister, a British surgeon who revolutionized surgery with his antiseptic techniques. Inspired by Pasteur's work, Lister proposed that airborne bacteria could infect wounds. By using carbolic acid to sterilize surgical instruments and clean wounds, he significantly reduced post-operative infections. Thanks a lot to him, modern antiseptic practices were born, making surgeries much safer. Next, we have innovative Paul Ehrlich, a German physician who bridged immunology and chemotherapy. His side chain theory explained how antibodies neutralized toxins, paving the way for modern immunology. Ehrlich dreamed of a finding magic bullet that could target pathogens without harming the host. His discovery of salvarsan, the first modern chemotherapeutic agent effective against syphilis, was a significant leap forward for medicine. Now, let's highlight Alexander Fleming, a Scottish bacteriologist whose discovery of penicillin in the year 1928 was nothing short of miraculous. He noticed that the mold Penicillium notatum has contaminated one of his petri dishes and was killing surrounding bacteria. This discovery led to the mass production of penicillin during World War II, revolutionizing bacterial infection treatment and ushering the antibiotic era. Can you believe that how one accidental discovery can change the course of medicine? Next up is Elie Metchnikoff, a Russian zoologist who unveiled the fascinating process of phagocytosis, where certain cells engulf and digest foreign particles. While studying starfish larvae, he stumbled upon the crucial immune defense mechanism and proposed the concept of innate immunity. For his groundbreaking work, he was awarded the Nobel Prize in the year 1908. Let's now talk about John Needham, an English naturalist who contributed to the theory of spontaneous generation. He boiled meat broths and observed the microbial life, mistakenly interpreting it as evidence that life could arise from non-living matter. His experiment faced criticism due to improper sterilization methods, leading to the eventual discrediting of spontaneous generation. Next, we have John Tyndall, an Irish physicist whose studies on air particles greatly advances microbiology. He demonstrated that air is filled with microorganisms and developed Tyndallization, a process to kill heat-resistant spores. His work provided vital evidences against spontaneous generation and strongly supported the germ theory of diseases. Now, let's talk about the Jules Bordet, a Belgian immunologist known for his groundbreaking discoveries in the immune system. He identified the complement system, a series of proteins that enhances immune responses, and received the Nobel Prize in the year 1919 for his discoveries. He also developed a vaccine for whooping cough, solidifying his legacy in the field of microbiology and immunology. Finally, we arrived at Karl Landsteiner, an Austrian immunologist who made waves with his discovery of ABO blood grouping system. His groundbreaking research not only made blood transfusion safer but laid the foundation of modern transfusion medicine. He got Nobel Prize in the year 1930 for his groundbreaking work. His work continues to save lives every day. In conclusion, each of these remarkable scientists had made monumental contributions that have shaped our understanding of microbiology and immunology. Their discoveries laid the groundwork for essential medicinal practices we rely on today, including vaccination, sterilization techniques, and antibiotics. As we continue to explore the world of microorganisms, their ongoing research is crucial for public health and our quest for new treatments. Thanks for joining me on this exciting journey.